Hello everyone, good morning. Very good morning. This is lecture number 2 of ordinary differential equations. So if you haven't watched the previous video, that is lecture number 1 on ODE, so you please watch that video and come back to this video, right? Because this is the continuation of the previous class. So previous class we have discussed about the syllabus for ordinary differential equations for UPSC Maths optional. And then we have said that we are going to start the first topic, which is solutions of differential equations of first order and first degree, right? So in the previous class, we have discussed about what is meant by a differential equation of first order and first degree. After that, I have said that there are many methods to solve an differential equations of first order and first degree, right? So I have listed out all the methods. So you can see I just show you the notes of the previous class. So in the previous class we have discussed about the syllabus, and then I have listed out there are many methods to solve a differential equations of first order and first degree. The first method is variable separable method, and the equations reducible to variable separable method, and then homogeneous equations, equation reducible to homogeneous, and then linear equations, equation reducible to linear, exact differentials, and integrating factor. These are the methods. So we are starting the first method. We have started the first method in the previous class itself, which is variable separable method. So before that, I have given you all the differentiation and integration formulas, right? I have given you, I have just recalled you what is the basic differentiation integration formulas. And these integrals are very, very important, right? These integrals are very, very important. Just have to memorize this quickly in order to solve differential equation problems very quickly. After that, we have introduced variable separable method. I have said when to use variable separable method. If you can able to separate x and dx to one side, that is functions of x and dx to one side, and functions of y's and dy's to other side, then you can do variable separable method. Then you have to integrate on both sides, right? In the previous class, we have solved almost 10 problems, right? The previous class, we have solved 10 problems. All 10 problems are based on variable separable method. So if you want the notes for this class, you can download that in Telegram group, the description, and even for Telegram. So we will start with the 11th problem, right? So in this class, we'll be finishing off the first method, which is variable separable method. And the next class, we'll be starting equation reducible to variable separable method, right? So in this class, again, we are going to solve problems based on variable separable method only. So we will start with the 11th problem. Is there any doubt up to now what we are doing? So we'll start with 11th problem. To solve x minus y square x dx minus y minus x square y dy is equal to 0, right? So all the problems we are going to solve only on variable separable method only. So we'll start with solution, right? So first what we'll do is we'll separate x and dx to one side and y and dy to other side. So we have x minus y square x dx is equal to y minus x square y dy. Let's take this x common. So we have 1 minus y square dx. I take this y common, we will have 1 minus x square dy. So what we will do is let us keep this y dy divided by 1 minus y square, right? And let us keep this x dx divided by 1 minus x square, right? So you can see I separated y's and dy's to one side, x and dx to other side. So we will integrate. So integrate on both sides. So integration of y divided by 1 minus y square dy. So is equal to integration of x dx divided by 1 minus x square, right? So we know integration of f dash of x by f of x, right? Is log f of x. So you can see 1 minus y square derivative is minus 2y, but this minus 2 is missing here. Let's do, let us add, let us multiply and divide by minus 2, right? So 1 minus, right? Let us multiply and divide by minus 2 and minus 2. So this will be 5. Again, here also, I'm going to multiply and divide by minus 2. Right, now you can see 1 minus f of x, f dash of x, f of x, f dash of x. So this will be log 1 minus y square will be log 1 minus x square. Let us add some constant, integration constant, log c. Minus 1 by 2 will get cancelled. And we know this is log of 1 minus y square, and log a plus log b will be log ab. This log will get cancelled. So 1 minus y square is equal to c into 1 minus x square is the required solution. Right? So again, a very simple problem. We move on to problem number 12, right? So try to solve every problem in your own. If you have any doubt, you just refer the solutions, right? Problem number. Solve dy by dx equal to xy plus x plus y plus 1. Okay? Xy plus x plus y plus 1. What we'll do is, let us take this x common here. So we will have y plus 1. I can write this as y plus 1. Let's try to factorize this. Will be x plus 1 into y plus 1, right? So we will have dy by y plus 1 is equal to x plus 1 into dx. So we have separated the variables, right? Variables are separated. Right? So variables are separated. So we'll integrate this. Integration of dy divided by y plus 1 is equal to integration of x plus 1 dx. So this is log y plus 1, right? F of x, f dash of x, and the integration of x dx is x squared by 2, and integration of 1 dx is x. Let's add some constant c. This is the required solution. If you want y is equal to, means you take e on both, exponential on both sides, so that y plus 1 will be e power, y plus 1 will be e power x squared by 2 plus x plus c, right? That is not required. It will stop at this stage. Required solution. Actually, we are finding a function y which differentiates once, gives you the value of xy plus x plus y plus 1. Take e on both sides, you will get y is equal to e power something. That is the required function. If you differentiate once, you will get xy plus x plus y. That's what it says. Problem number 13. So x into 1 plus x into 1 plus y square dx plus y into 1 plus x square dy is equal to 0, right? So we have x into 1 plus y square dx is equal to minus y into 1 plus x square dy. Let us take this y dy. Let's bring this 1 plus y square here. And let us keep this x dx. And we will bring this 1 plus x square here, right? So we have minus y dy by 1 plus y square, x dx by 1 plus x square. So again, you will integrate. So integration of y divided by 1 plus y square dy, or let us take this term this way, right? X dx by 1 plus x square is equal to 0. So if I integrate, this will be, again you can see this 2 is missing here, right? So if I differentiate this, you will have 2y. So what we will do is, we will multiply and divide by 2, and here also we will multiply and divide by 1 by 2. This will be log 1 plus y square, will be log 1 plus x square. Let's add some integration constant log c, right? So log a plus log b will be log ab. So the c will be 1 plus x square, 1 plus y square is the required solution. Right. So we move on to problem number 14. To solve, dy by dx is equal to e power 2x minus 3y plus 4x square e power 3y. Right, 4x square e power 3y. Check the question. E power 2x minus y to e power minus 3. Okay, so we have to separate the variables first and then we have to integrate. Okay, very simple problem. So we have dy by dx is equal to e power 2x into e power minus 3y, 4x square e power minus 3y. So if I take e power minus 3y outside, we have e power 2x plus e power 2x by 4x square. We have dy divided by e power minus 3y is equal to e power 2x plus 4x square dx, right? So we'll integrate this. Integration of e power 3y dy is equal to integration of e power 2x plus 4x square dx. So this will be e power 3y by 3 will be e power 2x by 2, right? And this will be 4x cubed by 3. Let us add some constant. So e power 3y by 3 is equal to e power 2x plus 4x cubed by 3 is the required answer. If you want, you can take LCM, right? If you want, you can take LCM. LCM will be 6, right? If you want, you can simplify this 2 more, right? It's the required solution. On to problem number 15. Solve x plus 1 into dy by dx plus 1 equal to 2 into e power minus 1, right? Solve this. So it's an interesting problem. So we have x plus 1 into dy by dx is equal to 2 into e power minus y minus 1, right? 2 into e power minus y, 2 into e power minus y minus 1. Okay. Let us separate the variables. So we have dy divided by 2 into e power minus y minus 1 is equal to dx by x plus 1, right? Dx by x plus 1. You always keep dy and dx in numerator. Variables are separated. Variables are separated. Okay. So what we can do is let us try. Let's write this e power minus I as 1 by e power y. So if we take LCM, we have e power y dy divided by 2 minus e power y, right? So 2 minus e power y by e power y. Let's take this e power y to that side. We have dx by x plus 1. Again, you can see f of x, f dash of x. But here we should have minus here, right? So if we differentiate this, we will have 0 minus e power minus y. So minus is missing here. So what we'll do is we will write this as minus of minus e power y divided by 2 minus e power y. So integration of dx by x plus 1, right? This will be minus log 2 minus e power y is equal to log x plus 1, and we will add some integration constant log c, right? This is the required solution, right? This is a required solution. If you want, you can also bring this term to that side. You can do like that. Let's try to bring this term to that side, that term to this side. So therefore, we will have log x plus 1 plus log 2 minus e power y is equal to log c. So even though we have minus log c, since it's a constant, no problem, right? Since it's a constant, no problem. And we know log a plus log b is log ab, and this log will get cancelled. So we have c is equal to x plus 1 into 2 power e power y. On to fifth problem. 16th problem. So solve dy by dx is equal to xy plus y divided by xy plus x, right? Xy plus x. Okay, I'm doing lots and lots of problems just to make you more convenient, right? So even if you see Rising India book, there is only 5 to 6 problems or maximum of 10 problems. But we are doing many problems from different textbook just to give you more practice so that when you look at the question itself, you can easily solve the problem. That is why I'm doing more problems, right? So I'm just reducing your work, right? So you have to search many books and then you have to do many problems. I'm just cutting the time for you. Just saving your time by just following my notes, right? You refer 2 to 3 books and practice problem means it take time for you. But I'm reducing time for you by doing I'm doing that work for you, right? Problem 15, problem 16. We have dy by dx is equal to, let us take this y common. We have x plus 1, let us take x common, we will have y plus 1. So we have dy divided by, let us take this y plus 1 here, y plus 1 dy, y plus 1 dy by y is equal to x plus 1 dx by x, right? X plus 1 dx by x. Let's divide this y separately. We will have 1 plus 1 by y dy equal to 1 plus 1 by x dx. Integrate this. Integration of dy is y and integration of 1 by y is log y. Integration of 1 dx is x and integration of this will be log x, right? So y plus log y is equal to x plus log x plus c is a required solution, right? If you want, you can take this x to that side, log y to that side, log x minus log y, and we know log a minus log b, log a by b will be log x by y plus c is a required solution. Right? Move on to 17th problem. So solve e power y plus 1 into cos x dx plus e power y sin x dy is equal to 0, right? Let's separate the variable first. So we have e power y plus 1 cos x dx is equal to minus e power y sin x dy. Let us take this e power y dy here. E power y dy divided by e power y plus 1. And we have let's take this cos x dx here. So we have cos x dx divided by sin x and we have minus sin here, right? So integrate on both sides. So if we integrate, we will have integration of e power y by e power y plus 1 dy and integration of cos x by sin x dx, right? And you know this is what? Integration of tan x, and you know integration of tan x is log cos x, right? Log cos x, sorry, log sin x, right? You can see f of x, f dash of x. Sin x derivative is cos x, right? Let's keep this minus as it is. So this is again f of x, f dash of x. This will be log e power y plus 1 log e power y plus 1 is equal to minus log of sin x, right? Log of sin x, and let us add some integration constant, and let us try to bring this term here. So we have log e power y plus 1 plus log sin x is equal to log c, and we know log a plus log b is log ab. So therefore we have e power y plus 1 sin x is equal to c, the required solution. On to 18th problem. X square x into cos square y dx is equal to y cos square x dy. Right, let's try to separate the variables first. So we have y dy. So we have y by cos square y dy by cos square y is equal to x dx divided by cos square x, right? So we have y dy divided by x cos square x. So I can write 1 by cos square y as secant square y. So y into secant square y dy is equal to x into secant square x dx, right? So integrate on both sides. To integrate, we will have y into secant square y dy is equal to integration of x into secant square x dx. Now let us do once, right? This is nothing but x and y are just dummy variables, right? When you perform one integral, from that answer you can just replace y by x to get this integral, right? So what we'll do is we'll only perform, we will find integration of y into secant square y dy, right? So we'll use integration by parts. So we know integration of u dv is uv minus integration of v du. You have to choose u in the order I late, right? ILATE. I stands for inverse trigonometric function, A stands for algebraic, T stands for trigonometric, E stands for exponential, right? L stands for logarithmic. You have to choose u. The previous class we have said, right, in this order. So like inverse, logarithmic, algebraic, trigonometric, and exponential. So here we have algebraic function and trigonometric function. Since A comes first, you choose u to be equal to y, and you choose dv to be equal to secant square y dy, right? This you have to differentiate. So du by dy respect to y will be 1. So that means du is equal to dy. This you have to integrate. So integration, because we need to find u and v, right? We need to find v. So since we know dv, to integrate we can find v. It will be integration of secant square dy. So what is this? What we know, integration, differentiation, inverse process. Which differentiation gives you secant square y? It is tan y, right? I have also given you the formula for this one, right? So tan y. So v is tan y. Therefore, the value of this will be integration of uv minus integration of v du. What is u? U is y. V is tan y. Right? V is tan y minus integration of v du. Integration of tan y dy. And again, what is integration of tan y? We know, right? So it is tan x. I can write as sin x by cos x. And that is nothing but log cos x, right? Will be y into tan y, and integration of tan y is what? I can write this as integration of tan y. Tan y is what? Sin x, sin y by cos y dy, right? Sin y by cos y dy. This is actually cos by sin. This is cot, right? Sorry, actually this is cos by sin. I said it is tan, right? Sorry, it is cot x. No problem. Derivative of sin x is cos x. So let us keep this minus as it is and write log sin, right? So again, sin y by cos y. You can see derivative of cos y is minus sin y. So what I'm going to do is let's take this minus to this side. So we have y tan y plus integration of minus sin y by cos y dy. Now I can write this as what? Y tan y plus log of cos y, right? So this is the integration value. Therefore, this will become, my voice is audible, right? My voice is audible, right? I think there is some internet. Okay, thank you, thank you. Okay, okay. So this value is y into tan y plus log cos y. Now similarly, you just change the variable of y to x. So this will be x into tan x plus log of cos x, right? Plus log of cos x. So this is the required, answer, right? So if you want, you can take log to one side and other to other side, the required solution. So problem number 19. Problem number 19 is solve secant square y tan y secant square x secant square x tan y dy plus secant square y tan x dx is equal to 0, right? Let's try to separate the variable first and then you need to integrate this. This will be secant square x tan y dy is equal to minus secant square y tan x dx. Let's keep this tan y dy divided by secant square y. Let's keep this tan x dx divided by secant square x, right? And we know f of x, f dash of x, right? So tan y dy divided by secant square y. So derivative of, okay, before that what we will do is, actually if I have tan y in the denominator means I can write log tan y, because derivative of tan y is secant square y, but we have this is opposite, right? Okay. We have to do some more method. Okay, no problem. Let us try to write this tan y as sin y by cos y. Let's try to write this 1 by secant square y as cos square y dy. Again, let's try to write this tan x as sin x by cos x and 1 by secant square y as cos square x dx. So this one cos will get cancelled. So we have sin y cos y dy. We have minus sin x cos x dx. And we know sin 2 theta is 2 sin theta cos theta, right? Sin 2 theta is 2 sin theta cos theta. So what we can do is, so here we have sin theta cos theta, right? Sin 2 theta is 2 sin theta cos theta. Let us write this as sin, let us multiply 2 on both sides. Let's multiply 2 on both sides, right? I have multiplied by 2. And now I can write this as sin 2y dy is equal to minus sin 2x dx. So you can see I separated the variable. So integrate this, integration of sin 2y dy is equal to minus integration of sin 2x dx. So sin 2y dy will be sin 2y is cos 2y minus cos 2y, right? So minus cos 2y divided by 2. Here also minus cos 2x by 2 plus we will add some constants c. So if we bring this term to that side, this side, that will be this is a required solution, right? on to problem number 20. So solve dy by dx tan y equal to sin x plus y plus sin x minus y. So what is sin a plus sin b? Sin a plus sin b. So sin a plus sin b is 2 sin a plus b by 2 cos a minus b by 2. These are the standard trigonometry formula. Sin a plus sin b is 2 sin a plus b by 2 cos a minus b by 2. Let's try to apply the formula here. Sin a plus sin b, 2 sin a plus b by 2 cos a minus b by 2. Right? A plus b by 2, a minus b by 2. So x plus y minus x plus y. This will be 2 times. So this y will get cancelled. So 2x by 2 will be x. The x will get cancelled. So 2y by 2 will be, we have cos y. So we have dy by dx tan y. Let us try to bring x term to one side, y term to other side. We have dy by dx tan y, right? Let's keep this dy tan y divided by cos y. We have 2 sin x dx, right? So 2 sin x dx. So integration of cos y tan y. I can write this cos y as secant y. Integration of secant y dy. So 2 times integration of sin x dx, right? Secant y tan. Is there any way to simplify more? And next I can write tan by cos square. Secant y tan y dy 2 sin x dx. We have to say now we have to do integration by parts. I think you can do this, right? We have to do integration by parts. So integration uv minus u dv, right? uv minus integral v dv. Any way to simplify this to more? Secant y tan y. So I can write this 1 by cos. Okay, this is very easy to perform. To perform this, let us take u to be equal to secant y and dv to be equal to tan y dy. So therefore, du by dy, right? So what is differentiation of secant square? What is secant square? Secant x tan x, right? Is secant y tan y. Therefore, du will be secant y tan y dy. What about v? Integration of tan y is log v minus log cos x, right? Like write tan y as sin y by cos y. V minus log cos x. Right? Minus log cos x, or I can also write that as a log of mod secant x. Write that as mod secant x. So if I do uv minus integration of v du, u is secant y, b is minus log cos x. No, actually we are doing silly things, right? Integration of secant y tan y itself we know, right? Is secant y. Sorry. Not the direct formula itself. Integration of secant y tan y is secant y, right? Which function you differentiate to get secant y tan y is secant y, right? Sorry. Actually, what you can do is you can write that as d by dx of secant y, right? Because d by dx secant y is secant y tan y. Now this will get cancelled. This integration differential will get cancelled as it is inverse process. This is nothing but secant y. This is nothing but secant y. And integration of sin x is minus cos x. The required solution. Right? Easy problem. So we'll move on to 21st problem. All dy by dx plus root of 1 minus y square by 1 minus x square is equal to 0. So we have dy by dx is equal to minus root of 1 minus y square divided by root of 1 minus x square. So we have dy divided by root of 1 minus y square is equal to minus dx divided by root of 1 minus x square. And we know integration of dx divided by root of a square minus x square, right? I have given you the formula root of 1 a square minus x square. So see 1 divided by root of a square minus x square is sine inverse of x by a plus c, right? Sine inverse of x by a plus c. This will be sine inverse of x by a plus c. So here we have a to be equal to 1. This is nothing but sine inverse of y. Here we have this is to be equal to sine inverse of x. And we will add constant to be sine inverse of c. So we have sine inverse of x plus sine inverse of y is equal to sine inverse of c. And from inverse trigonometric function, sine inverse of a plus sine inverse of b, we have some formula. This is sine inverse of x into root of 1 minus y square plus y into root of 1 minus x square, right? And this is sine inverse of c. Sine inverse will get cancelled. So we have x into root of 1 minus square plus y into root of 1 minus x square is equal to c is equal. We move on to 22nd problem. So solve dy by dx is equal to 1 plus y square by 1 plus x square. So we have dy divided by 1 plus y square is equal to dx by 1 plus x square. And we know integration of dx by a square plus x square is 1 by a tan inverse x by a plus c. I've given you all the formula. This is nothing but tan inverse of y. This is nothing but tan inverse of x. Tan inverse of y. This is tan inverse of x. Just adds up constant c, right? This is tan inverse of y minus tan inverse of x is equal to tan inverse of c. And we know tan inverse of a minus tan inverse of b. So what is formula for this? It is tan inverse of a minus b divided by 1 plus ab, right? And the tan inverse of a plus tan inverse of b will be tan inverse of a plus b divided by 1 minus a, right? These are the two formulas based on tan inverse, right? Okay. Now you can do this, right? So tan inverse of A minus tan inverse of B, you know. Actually, this will be A, B should be less than 1. Right? There is some condition on A and B, right? There is some condition on A and B. Use this formula. Tan inverse of A is AB has to be greater than 0. AB has to be greater than minus. So use this formula. Here AB has to be less than 1. Use this formula. A greater than 0, B greater than 0. Basis ID. So for using this formula, AB has to be less than 1, A and B has to be greater than 0. Okay, so we'll use this tan inverse of y minus tan inverse of x, which will be tan inverse of y minus x divided by 1 plus xy is equal to tan inverse c. The c will, tan will get cancelled. C is equal to y minus y plus x is equal. Right, so move on to 23rd problem. Problem number 23rd is very important, right? 23rd is very important. 23rd problem. Solve y into root of y into root of 1 plus x square dx plus x into root of 1 plus y square dy is equal to 0. Very important problem. So we have y into root of 1 plus x square dx is equal to minus x into root of 1 plus y square dy. Let's try to separate the variable. So we have root of 1 plus y square dy divided by y, right? Divided by y. And here we have minus root of 1 plus x square dx divided by x, right? Or you can also write this as 1 root of 1 plus y square by y dy plus root of 1 plus x square by x dx equal to 0. Now integrate this, right? Now integrate this. Let us call this as I1 plus I2. Right? Call this as I1 plus I2 is equal to 0. Now we need to find the value of I1 and I2. Interesting. So we have I1 to be equal to integration of root of 1 plus y square by y dy, right? What I'm going to do is I'm just going to multiply and divide by root of 1 plus y square, root of 1 plus y square, right? Root of 1 plus y square, root of 1 plus y square. Why I'm doing this? Because you come to know very quickly. Right? Because it is not a direct formula, right? F of x, f dash of x. There is no any pattern like that. So now what I'm going to do is I'm going to write this as integration of, so root of 1 plus y square, root of 1 plus y square is plus y square, y into root of 1 plus y square dy. Now I'm going to separate this as integration of 1 divided by y into root of 1 plus y square dy plus integration of y square divided by y into root of 1 plus y square dy. So this will be integration of y into root of 1 plus y square dy. This one y will get cancelled. So we have y divided by root of 1 plus y square dy. Right? Let us call this as some, we need to perform this integral also, right? Let us call this as some a1 plus a2, right? Now we will find a1 and a2 and then we will substitute here, right? Now what is a1? See, if you perform this integral, this is nothing but you just have to change the variables of y to change the variables of x. That's it, right? So perform this integral is same as perform this integral. You just have to convert y to x. That's it. Now what is a1? So a1 is integration of 1 divided by y into root of 1 plus y square dy. Remember, this is not a rational function, right? As you can see, the degree is 1 by 2 here, right? So it has to be in the whole numbers. Degree has to be for polynomial. Okay. What I'm going to do is put y is equal to 1 by t. Now what about dy by dt? Will be minus 1 by t square, right? Derivative of 1 by x is minus 1 by x square. So therefore we have dy is equal to minus dt by t square. So after performing this, you can, this will be integration of y divided by, so y is 1 by t root of 1 plus y is 1 by t into dy. So dy is minus dt by t square, right? Minus dt by t square. So this will be integration of 1 divided by, so 1 by t. So here we have root of 1 plus t square by t, right? So we bring this t square to that, in the out of root, we have t and we have 1 plus t square and we have minus dt by t square. So this t square, right, will get cancelled. So we have minus dt by root of 1 plus t square. That's it. So what is integration of a square plus x square root of, right? So I'll give you the formula, right? Integration of 1 divided by root of a square plus x square. So integration of 1 divided by root of a square plus x square. Yes, here you can see 1 divided by root of a square plus x square is log x plus root of x square plus a square. Log x plus root of x square plus a square plus c. So here you can see our a is 1 and x is t, right? A is 1, our x is t. So this will be minus, already we have minus here. So we have log of t plus root of t square plus 1, right? T square plus 1. So just change t to be equal to 1 by y. You will get the value of a1, right? You will get the value of a1. Let replace t is equal to 1 by y, right? Because y is 1 by t is 1 by y, minus log 1 by y root of 1 by y square plus, right? So this is the a1 value. Now similarly we will find a2. So what is a2? So a2 is a2, right? a2 is this a2, right? Integration of, see, we are finding i1 plus i2. In i1 I'm just multiplying by root of 1 plus y square by root of 1 plus y square, and then I'm again separate this into two integrals, which is a1 plus a2. a1 we have found. Now we need to find a2. So a2 is integration of y divided by root of 1 plus y square dy, right? Okay, let's put t is equal to 1 plus y square, right? So put t is equal to 1 plus y square, or 1 plus y square to be equal to t. Now what about dy by dt? Put 1 plus y square to be equal to t. So differentiate with respect to t. So we will have 2y dy by dt is equal to 1, right? So we have y dy to be equal to dt by 2, right? So y dy to be equal to dt by 2. So this will be integration of, so I can write this y dy to be equal to dt by 2. This will be 1 divided by root of e, and y dy is dt by 2, right? This will be 1 by 2 integration of t power minus 1 by 2 dt. So this will be 1 by 2 t power minus 1 by 2 plus 1 by 2 plus 1. These two will get cancelled. So we have this to be equal to t power 1 by 2. Now replace t to be equal to 1 plus y square. So this will be root of 1 plus y square. So root of 1 plus y square is a2 value. So therefore 1 becomes, right? So 1 becomes, this is very important problem, right? So you just understand, whenever you have y by root of 1 plus y square, you make use of this substitution. You will be getting this often. 1 divided by y into root of 1 plus y square, you make this substitution, right? So 1 becomes, so we have I1 plus I2 is 0. And what is I1? I1 is A1 plus A2, right? So this will be minus log 1 by y plus root of 1 by y square plus 1, plus I2 is root of 1 plus y. I1 is A1 plus A2. Similarly, I2, you just change the variable to x. Is the required solution. Right? After finding I1 for I2, same integration. Only thing is variables of y are in variables of x. So this is the value of I1, right? This is the value of I1, and this is I2. So just convert the variables of y to variables of x. We'll get the integration for that, right? Okay. Well, problem 23 is over now. We'll move on to problem number 24. So solve y minus x into dy by dx equal to 3 into 1 plus x square dy by dx. Okay. So what we'll do is we'll separate the variables and then we will do. So we have y minus x into dy by dx is equal to 3 plus 3x square dy by dx. We can write this as y minus 3 is equal to 3x square dy by dx plus x into dy by dx. Y minus 3 is equal to, so if I take 3x square plus x outside, so we have dy by dx. So we have dy divided by y minus 3 is equal to dx divided by, if I take is x outside, we have dx plus 1, right? So integrate this. This will be log y minus 3. Let's call this as sum I1 plus c. Now to find I1, you can see this is a proper rational function, right? Degree of numerator is 0, degree of denominator is 2. This is a proper rational function. which is x into 3x plus 1 dx, right? So for that, you have to do partial fraction. So you just do partial fraction for 1 divided by x into 3x plus 1. So we have a by x plus b by 3x plus 1. So we'll multiply by x into 3x plus 1 throughout. So we have 1 is equal to a into 3x plus 1, b into x, b into x. So we need to find the values of a and b. So put x is equal to 0. So therefore our a will be equal to 1. So if you put x is equal to minus 1 by 3, right? If you put x is equal to minus 1 by 3, this will be 0. So this will be minus 1 by 3. B is equal to minus 3. Right? Therefore I can write, therefore a is 1, b is minus 3. The integration of 1 divided by x into 3x plus 1, integration of a by x plus b by 3x plus 1 dx. So integration of a is 1, so by x, b is minus 3, dx plus 1 dx, right? So again you can see this is f of x, f dash of x, this is log x, and this is already we have 3, right? This is nothing but log of 3x plus 1. Okay, f of x, f dash of x, plus we will add some constant c. Right? So this is the required solution. So we have, let's call this as 1. 1 becomes log y minus 3 is equal to, so we know log a by b is log a by b, log a minus log b, plus we will add some constant c, right? Log y minus 3 is equal to, let's call this as some log c. So we will have y minus 3 is equal to log a plus log b is log ab, so 3x by 3x plus 1. It's a required solution. It's the required solution, right? Okay. Not a problem. Number 25. So solve it to dy by dx plus y square plus y plus 1 divided by x square plus x plus 1 is equal to 0. Right? So we have dy by dx is equal to minus of y square plus y plus 1 divided by x square plus x plus 1, right? So I think there is some pressure cooker whistle is going on outside, so sorry for that. So we have dy divided by y square plus y plus 1 plus dx divided by x square plus x plus 1 is equal to 0, right? Separate the variable and bring this minus on that side. Now we need to integrate this, right? Integrate this. Now how to integrate this? If you integrate this is enough, right? Just have to change the variable of y to x. Now, so how to integrate 1 divided by y square plus y plus, sorry, this one. Now, whenever you have something by quadratic, right? Whenever you have something by quadratic, you have to follow this method, right? So these are just 11th standard integrals. So whenever you have something by quadratic means, first what you have to do is you have to do completing the square, right? You have to do the completing the square for this quadratic equation, right? Something by quadratic, 1 by quadratic. So if you have 1 by quadratic, you have to make use of completing the square here. So 1 divided by, so how you do completing the square, add and subtract coefficient of, add and subtract coefficient of x by 2 whole square, right? That is, if you have ax square plus bx plus c, you just have to add and subtract coefficient of x by 2 whole square. So here it is in terms of y. So what is coefficient of y? It is 1. So we just have to add and subtract plus or minus 1 by 2 whole square. We just add and subtract plus or minus 1 by 4. So we have y square plus y plus 1 by 4 minus 1 by 4. Already we have plus 1, right? We have just added and subtracted this term. Coefficient of y by 2. Coefficient of y by 2 is 1 by 2. Coefficient of y by 2. Coefficient of y is 1, right? Coefficient of x by 2 whole square. Okay. The coefficient of x, not a bracket here. Coefficient of x by 2 whole square, right? So coefficient of x is 1. So we have here the coefficient of y, which is 1. So 1 by 2 whole square. So which is plus or minus 1 by 4, right? Completing the square, this is 8th standard level. Now I can combine the first 3 terms and I can write this as integration of 1 divided by y plus 1 by 2 whole square, right? So these 3 terms, and 1 minus 1 by 4 plus 1, 3 by 4. By, and this is integration of 1 divided by y plus 1 by 2 whole square, and I can write this as root 3 by 2 whole square. Now integration of 1 divided by x square plus a square, or a square plus x square. What is this formula? 1 by a tan inverse of x by a plus c. So instead of x, we have y plus 1 by 2. Instead of a, we have root 3 by 2. So 1 by a tan inverse of x by a plus c, right? So just have to replace 1 by a square plus x square, right? 1 by a square plus x square, you just replace x by that term by this term. So this will be 2 by root 3. This will be 2 by root 3. And this is tan inverse of, I can take this tan of x. So just have to do simplification, right? Tan inverse of root 3 by 2. So 2 by root 3 into 2y plus 1 by 2, right? We will take LCM plus c. This is the value of this. So similarly, what you can do is you just have to replace. Let's call this as I1 plus I2 is 0. This is the value of I1, right? So substitute in 1 to get the answer. Right? So substitute in 1 is the required solution. See, we have performed the integral, right? After that, you just have to put y to be equal to x to get the value of I2, because both I1 and I2 are same. So remember, the important trick here is whenever you have 1 by quadratic equation, you make use of completing the square and make use of this formula, right? 1 by x square plus a square dx. So problem number 26, which will be the UPSC, previous year's UPSC question. We're doing this now. Still we have 4 more problems, that's it. Solve. X dx plus y dy divided by x dy minus y dx equal to root of a square minus square minus. Okay. So you can see whenever you have something like x square plus y square, what you can think of? What you can think of? Here you can see if I take minus outside, this will be x square plus y square. This will be x square plus y square. Right? Whenever you think of x square plus y square, you just change that to polar form. So that this entire term will be equal to what? We put x is equal to r cos theta, x is equal to r cos theta, y to be equal to r sin theta. This entire term will be reduced to r square. This entire term will reduce to r square, right? So what I'm going to do is I'm just going to convert this to polar form, right? So put x to be equal to r cos theta and y to be equal to r sin theta. So that what about x square plus y square? So it is r square sin square theta, r square cos square theta. This is nothing but r square, right? So sin square theta plus cos square theta is 1. And we know r is root of x square plus y square. And what about theta? Theta is tan inverse of y by x, right? If we divide x by y, so we will have r cos theta by r sin theta. Or if we divide y by x, so that r will be so that r will be root of x square plus y square. And what about y by x? Y by x will be r sin theta by r cos theta, which is this tan theta. So therefore theta will be tan inverse of y by x. These are very elementary, we know. So what I'm going to do is I'm just going to make use of this substitution now. After the substitution, you can see what it gets happened. Right? Okay. Now, after the substitution, we need dx and dy, right? So we have x is equal to r cos theta. I'm just going to make use of implicit differentiation. So we have x to be equal to r cos theta. So differentiate with respect to theta. So we have dx by d theta. Just make use of UV method. So r into differentiation of cos theta is minus sin theta plus, let us keep this cos theta as it is. And dr, r will be dr by d theta. Right? This is dr by d theta. And we have y to be equal to now dx by dt. Okay. And we have y to be equal to r sin theta, right? X. Dx by d theta dy. Right? Dx by dt. And we have y to be equal to r sin theta. What about dy by d theta? So derivative of sin theta is cos theta plus sin theta into dr by dt. Right? Make use of product rule. Okay. So you can see, let us call this as 1. I'm going to write 1 as rewrite, right? So rewrite 1 as, so x into, I'm just going to write this as dx by theta, d theta, y into dy by d theta, divided by x into dy by d theta, y into dx by d theta, right? Just dividing by d theta. And this will be root of, I take this minus outside, we will have x square plus y square divided by x square plus y square, right? Now make use of all the substitution, right? Make use of all the substitution. Replace x by r cos theta, dx by d theta by this term, and x square plus y square to be equal to r square, right? I'm converting everything in terms of x comma y to r comma theta. Converting Cartesian to polar. So x into dx by d theta. So what is x? X is r cos theta into dx by d theta. So dx by d theta is minus r sin theta plus cos theta dr by d theta, cos theta dr theta plus y. So y is r sin theta dy by d theta. So dy by d theta is r cos theta plus sin theta dr by d theta divided by, right, x into dy by d theta. So x is r cos theta, dy by d theta is r cos theta plus sin theta dr by d theta minus y dx. So y is r sin theta into dx by d theta minus r sin theta plus cos theta dr by d theta dr by d theta is equal to root of a square minus r square by r square, right? So because x square plus y square is r square, and again x square plus y square is r square, right? Okay. Now we'll simplify this. You can see this is r square. If I multiply this term, these two terms will get cancelled, right? These two terms will get cancelled, right? So minus r square sin theta cos theta plus r square sin theta cos theta. So these two terms will get cancelled, and again r square cos square theta, this is dy okay. This term will get, we have r square, think, okay, let us do one step by step. Right? So if I multiply this, we will have minus r square theta cos theta plus r into cos square theta dr by d theta. Here we have r square sin theta cos theta plus r into sin square theta dr by d theta whole divided by, here we have r square cos square theta plus r into sin theta cos theta dr by d theta. Here we have plus r square sin square theta minus r into sin theta cos theta dr by d theta is equal to root of a square minus r square by r, right? Okay, now you can see this term will get cancelled. This term will get cancelled. Now if I take dr by d theta outside, right? If I take r into dr by d theta common, we have sin square theta plus cos square theta, and here if I take r square common, we have sin square theta plus cos square theta root of a square minus r square by r. This will be 1, this will be 1. This 1 r will get cancelled. So we have dr by d theta divided by r is equal to root of a square minus r square by r. Again this r will get cancelled. So we have dr divided by root of a square minus r square is equal to d theta. Right? That's it. As you can see how the integral has reduced after substituting x to be equal to r cos theta, y to be equal to r sin theta. Now integrate. So what is root of a square minus r square? Is sine inverse of r by a. This is theta plus we'll add some constant c. So we have r by a to be equal to sine theta plus c. R is equal to a into sine theta plus c. Where we know r is root of x square plus y square. Where r is root of x square plus y square. That is I'm trying to write in terms of Cartesian, right? In terms of Cartesian, and the theta is tan inverse of y by x, right? Is a required solution. It's a very interesting problem. So just convert to polar form by using the substitution x is equal to r cos theta and y to be equal to r sin theta, right? So r is equal to a sin theta plus c is the required solution. Number 27. So root of 1 plus x square plus y square plus x square y square xy dy by dx is equal to 0. Okay. Again, this is important problem. So we have root of 1 plus x square. Let's take this x square outside here. Plus square equal to minus xy dy by dx. This root of plus x square into 1 plus y square minus xy dy by dx, right? Minus xy dy by dx. And this is root of 1 plus x square into root of 1 plus y square is equal to minus xy dy by dx. Now separate the variable, right? So we have y dy y by root of 1 plus y square dy plus root of plus x square by x dx, right, is equal to 0. Now you know how to evaluate both the integral, right? We have already evaluated both the integral. So for this, you put t to be equal to 1 plus y square, so that this will be root of 1 plus y square will be the answer. And also you know how to evaluate this also, right? You just multiply and divide by root of 1 plus x square both the term. See, you have already evaluated both the integral, right? You can see in this problem, you know how to evaluate root of 1 plus y square by y. How you evaluate root of 1 plus y square by y? That is what same here, right? It is in terms of x. So root of 1 plus x square by x, right? So you just have to multiply and divide by root of 1 plus x square, and then you have to put x is equal to 1 by t, so that you can get this integral. And similarly for this, we already evaluated this, right? Put t is equal to 1 plus y square, so that this will be, the answer will be root of 1 plus y square. It will be root of 1 plus y square, right? So refer, I think you can do, right? Or I want to do same problem. You want me to do? So refer problem number. We already evaluated both the integral, right? So for this, okay, let's call this as I1 and I2. I'll do this. So I1 is, integrate this also. So I1 is integration of y divided by root of 1 plus y square dy. So put 1 plus y square to be equal to t. So differentiate with respect to t. So we have 2y dy by dt equal to 1. Right? So we have y dy to be equal to dt by 2. So this will be integration of, so y dy is dt by 2 by 2 integration of t power minus 1 by 2 dt 1 by 2 t power minus 1 by 2 plus 1 by 2 plus 1, and this will be root t, so which is root of 1 plus y square. And similarly for I2, so I2 is integration of root of 1 plus x square by x. So just multiply and divide by root of 1 plus x square, root of 1 plus x square will be integration of 1 plus x square divided by x into root of 1 plus x square dx. Now you write this as 1 by x into root of 1 plus x square x square divided by x into root of 1 plus x square dx. This will be dx divided by x into root of 1 plus x square, and x will get cancelled. X divided by root of 1 plus x square dx. Call this as a1 plus a2. Now for a1, integration of dx by x into root of 1 plus x square. Put x is equal to 1 by t. Therefore, dx by dt will be minus 1 by t square. So differentiate with respect to t. So we have dx to be equal to minus dt by t square. This will be integration of x is 1 by t plus 1 by t square, and dx is minus dt by t square. So we will have dt divided by, so this t square will get cancelled. Root of 1 plus t square, minus outside. So minus, so root of a square plus x square, log of t plus root of t square plus 1 is a1 value. And similarly, a2 is same as this I1, right? Y divided by root of 1 plus y square. So you will get a2 to be equal to root of 1 plus x square is your a2 integral value. Substitute in 1, that will be the required answer, right? I1 plus I2, required solution is I1 plus I2 is equal to 0. What is I1? I1 is root of 1 plus y square, and I2 is a1 plus a2. So a1 plus a2 is equal to 0. Substitute this a1, a2 value here. Replace t to be equal to 1 by x, right? Here replace t to be equal to 1 by x, so that substitute this a1 plus a2 to get the required answer, right? So problem 28. If dy by dx is equal to e power x plus y, and it is given that for x is equal to 1, y is 1. Find y when x is minus 1. Right? So they have given the some initial condition just to find you the value of the arbitrary constant. So we will solve this equation. First we will find the solution. We need to find the solution. We need to find the value of y when x is minus 1. So we have dy by dx is equal to e power x plus y. So we have dy by dx to be equal to e power x into e power y. So we have dy by e power y is equal to e power x dx. So we have integration of e power minus y dy is equal to integration of e power x dx. This is e power minus 1 by minus 1, e power x by 1 plus constant c, right? Now we need to find the value of c. Actually, this is a solution. E power minus y is equal to e power x. Okay. Now to find c, right? So to find c, they have given that x is equal to 1, y is 1. Substitute this value here. So e power minus 1 by minus 1 is equal to e power 1 plus c. So I can write this as minus 1 by e, right? Already we have minus here. E power minus 1 is 1 by e. C equal to e plus c. So minus 1 by e minus e is equal to c. Minus 1 minus e square by e is equal to c, right? So therefore, the value of c is minus of 1 plus e square by e, right? The value of c is minus of 1 plus e square by e. This is a solution, right? So 1 becomes minus e power minus y is equal to e power x plus c. Okay, this is the solution. Now we need to find y when x is minus 1. So to find y when x is minus 1, substitute x to be equal to minus 1, right? You just substitute x to be equal to minus 1. So when x is minus 1, this will be minus e power minus y, e power minus 1 minus 1 by e plus, just bring this minus side, minus 1 by e plus minus 1 by e, this e will get cancelled. So we have minus e, right? Right. So if you bring this 1 by e square by e. So this e power minus 1 and this will get cancelled, right? So we have minus e power minus y is equal to minus e. Again, this will get cancelled. So that means what? Bases are same. So minus y is equal to 1. Y is minus 1. Right? So therefore, when x is minus 1, y is minus 1. It is the required solution. On 29th problem. Twenty-ninth problem, I'll just give you a hint. You just solve that. Find the particular solution of the differential equation log of dy by dx is equal to dx plus 4y, given that y is 0 when x is equal to 0. So they are giving this just to give you the value of, just to find you the value of c, right? So we have log of dy by dx is equal to dx plus 4y. You take e on both sides. So that means dy by dx is equal to e power 3x plus 4y. Right? So therefore we have dy by dx is equal to e power 3x into e power 4y. So we have dy divided by e power 4y, e power 3x by dx, right? Now to find c, you just make use of the condition that it is given that y is 0 when x is 0. So to find c, it is given that y is 0 when x is 0. So when you substitute both to be equal to 0, e power 0 is 1. Okay, this is 1 plus c. So just bring this term minus 1 by 4 minus 1 by 3. So it will be minus 7 by 12, right? So substitute back here is the required solution, right? Right? Okay, so problem number 30. So last problem that you're going to do, right? Last problem that we're going to do. After that, we're going to wind up the class. So that I'm going to give you one exercise problem that I'll give you the solution alone, right? I'm not going to solve that. The line normal to the curve, the line normal to the curve at each point x comma y on the curve passes through the point 2 comma 0. If the curve contains the point 2 comma 3, find its equation. Right? Very interesting problem. The line normal to the curve passes through the point. Okay, the line normal to the curve at each point x comma y on the curve passes through the point 2 comma 0. Okay, the normal of the line normal to the curve at each point x comma y passes through 2 comma 0. The curve contains the point 2 comma 3. Find its equation. Right? We'll do this very easy problem. Let us try to draw the graph, right? So we have a curve, right? So we have a curve y is equal to f of x. Let us take a point x comma y. So if we take a point x comma y, this will be the tangent, right? This will be the tangent. This is the tangent at the point x comma y, and we know the tangent at this point, right? Okay, let us keep this as and we know a line that is perpendicular to tangent is normal, right? Right. So therefore, the normal will be like this. Right? This is the normal, and this normal passes through the point 2 comma 0. Right? This is normal. This tangent, right? So we have a curve y is equal to f of x. Actually, we need to find the equation of this curve y is equal to f of x. Okay. We need to find okay, and also it is mentioned that the curve contains the point 2 comma 3. So that means the curve passes through the point 2 comma 3, right? So we need to find the equation of this curve. To find the equation of this curve. Right? So we at x comma y, we have a tangent and we have a normal. Normal passes through the point 2 comma 0. Okay, so we need to find the equation of this curve y. Right? Now, what is the slope of normal? So we know 2 points in the line, right? So from the diagram, we know. So what is the slope of normal? So we know 2 points, right? So one is 2 comma 0 and other is x comma y. So slope of slope what? What is slope of it is y2 minus y1 divided by x2 minus x1, right? So y2 y1 divided by x2 minus x1. So y by x minus 2 is the slope of normal, and also we know, right? So we have slope of normal to be equal to y divided by x minus 2. Call this as equation number 1, right? Also we know if two lines are perpendicular, the product of their slopes is -1, right? So this is a very elementary result from a coordinate geometry. If two lines are perpendicular, the product of their slopes is -1, right? So we know the slope of tangent, sorry, the line, tangent line and normal line are perpendicular. So we know that slope of tangent into slope of normal will be -1, right? So that means what is slope of tangent? What is the slope? Slope of tangent. It is nothing but dy by dx, right? Very simple, right? So we have curve y at a point x comma y. It is nothing but dy by dx. So slope will be dy by dx, right? Dy by dx at the point x comma y, right? Okay. Slope will be dy by dx at the point x comma y. This will be some number that will be the slope. Okay. So what is slope? It is dy by dx into slope of normal is equal to -1, right? So that means from this data, the slope of normal is minus dx by dy, right? We just take this dx dy to that side. Let's call this as 2. So from 1 and 2, we have both the slopes has to be equal, right? So from 1 and 2, we should have minus dx by dy has to be equal to y divided by x minus 2, right? So solve the differential equation, solve this by separating the variable. You can find the equation of the curve, right? Very interesting problem, right? So we have minus dx by dy is equal to y divided by x minus 2. So we have minus dx into x minus 2 is equal to y into dy. Let's call this as 2 minus x and omit this minus. So we have y dy is equal to 2. Actually, you can see all the variables separated, right? Okay. So integrate. So we have 2x minus x square by 2 is equal to y square by 2 plus c. Is the required solution, but we don't know what is c, right? But we don't know what is c. X square by 2 minus 2x is the required solution, but we don't know what is c. Now to find c, we know that the curve passes through the point 2 comma 0, right? 2 comma 3. So it passes through 2 comma 3. That means it will satisfy this equation. So 2 into 2 minus 2 square by 2, right? Minus 2 square by 2 is equal to y square. So therefore, what will be the value of c? It will be 4 minus 4 by 2. Yes, this will be 4. So this will be 8 minus 4. Right? 4 minus 4 by 2. It will be 8 minus 4. It will be 4 minus 2 equal to 9 by 2 plus c. So 2 minus 9 by 2 is equal to c. So c is 5 by 2, right? C is 5 by 2. Substitute back here. Substitute in 1. So 2x minus x square by 2 is equal to y square by 2 plus c is 5 by 2. Let's multiply this 2 here, right? So we have 4x minus x square is equal to, let's multiply 2 so that I can cancel every 2, right? 2 into 2. So that means if we take that to this side, we will have x square plus y square, x square plus y square minus 4x, right? X square plus y square minus 4x We are doing right? This is minus 5 by 2, right? 4 minus 9. Sorry. 4 minus 9 minus 5 by 2. X square plus y square minus 4x is equal to 5. Is the required curve. Right? Very interesting problem. Actually, if you look, this will be some conic, right? This will be some conic. It will be a parabolic or it will be a circle or ellipse or hyperbola that you have to find, right? That we don't know, that we don't need to do, but it will be some ellipse. Sorry, it will be some conics, right? It can be a circle or it can be an ellipse or it can be an hyperbola. So that's it. Actually, one problem, I'll just give you the solution. You just go through this. Just go through that problem. It involves some trigonometric formulas. I'll just give you. I'll just give you the solution for that. It's very simple problem, but I'm not going to do that. So we are going to complete that variable separable method. So problem number 31. Solve 3 plus 2 sin x plus cos x dy is equal to 1 plus 2 sin y cos y dx, right? I'll just give you the solution for this, right? It just involves some trigonometric formulas and then you have to simplify. Just go through the solution, right? So you can see they have just separated the variable first. Right? Just separate the variable first. Dy, just multiply that and separate the variable. Integrate. So 1 plus cos y, 2 sin y. And here 1 plus cos x plus 2 sin x, right? Now 1 plus cos theta is 2 cos square theta by 2. And we know sin 1 plus cos x is 2 cos square x by 2. They are using some trigonometric formulas. 1 plus cos x is 2 cos square x by 2. And we know sine 2 theta is 2 sine theta cos theta. And therefore, sine theta will be 2 sine theta by 2 cos theta by 2. So, you just replace sine y to be 2 sine y by 2 cos y by 2. So, 2 will be 4. So, we'll have 4 sine y by 2 cos y by 2. 1 plus cos y is 2 cos square y by 2. And again, they have just writing this term as secant square y by 2 by 1 plus 2 by 2 plus 4 tan y by 2. If you can write tan y by 2 as sin y by 2 by cos y by 2. This has 1 by cos square y by 2. If we simplify this, we'll get this term, right? After that, we are making a substitution and then bringing the formula 1 by 1 plus 2t, which is nothing but f of x, f dash of x. So 2 is missing. Multiply and divide by 2. So this integral is over. Similarly, for this integral, what they are doing is they are writing this as 3 as 2 plus 1 and 1 plus cos x is 2 cos square x by 2. And again, sin x is 2 sin x by 2 cos x by 2. Already we have 2 here. So 2 into 2 will be 4, right? And similarly, they are writing this as secant square x by 2 by like this term. And you just substitute z to be equal to tan x, z to be equal to tan x by 2. So you can see something by quadratic, right? So if you have something by quadratic, what you have to do? You have to do completing the square. Very simple, right? Just to practice it, it will be very easy. So coefficient of z by 2 whole square. So z by 2 to 2 by 2, which is 1. Add and subtract plus 1 and minus 1. Already we have 2. So this will be, if I combine these three terms, this will be z plus 1 whole square, and 2 minus 1 is 1. So 1 by x square plus a square is tan inverse of x by a. So 1 by a tan inverse of x by a. So x is z plus 1, a is 1, right? So make use of that formula, and then you replace z to be equal to tan x by 2, right? The only thing is you just have to make use of this formula, and you have to remember these steps, right? This from this step to this step, they are making use of this to write like this, right? And then you know these two identities, right? 1 plus tan y by 2. After that, you make use of substitution, and then you can get the answer, right? So just go through this problem. So that's it. You have completed 19, almost all problems on variable separable method. I think you can do any problem on variable separable method from now on, right? Yes, you can do, right? The next class, what we're going to do is we are going to start the second topic, which is equations reducible to variable separable method, right? Equation reducible to variable separable method. After that, we'll be moving on to the next method, which is homogeneous equation, right? Any doubt? No doubt, right? If no doubt, we will wind up. Can we start LPP simultaneously? The 6 are watching. If you are okay, I will start LPP tonight, right? We'll start LPP also, so that you don't need to study only ODE at a time, so that you will have some diversion between LPP and ODE, right? So if you are okay, we will start LPP also. Night class, I will take LPP, right? If you are okay. So we will simultaneously do ODE and LPP. If you are okay. Right? Linear programming, right? LPP. Linear programming problem. That will be very, very interesting. It will give you more time pass, mental freeness to the problem. Okay, so thank you. In the Telegram, I will ask that question, right? Okay, thank you. The next class, we will see. Thank you. All the best. Bye. Bye. Okay, okay. Okay, so we'll start LPP also, right? I will update the Telegram group about evening class. If you haven't joined Telegram group, just go join that. Use the link in the description. I will post a PDF of this in the Telegram group. Right? Thank you.